Hi dear friends. Dear friends, in the previous part of the video online lecture we discussed about the breeder reactor, and after the breeder reactor we also discussed about the nuclear fusion. Breeder reactor, it is quite different from the power reactor and the nuclear reactor whenever compared, and then you will come to know that in case of a breeder reactor the amount of nuclear fuel goes on increasing, because the whatever amount of energy or the nuclear power or the electric power is obtained, which is greater than the consumption of the nuclear fuel. And this is one of the important characteristic of breeder reactor, and I think that's why it is one of the important thing to discuss the breeder reactor, because in this case, or it is the only device in which the amount of nuclear fuel goes on increasing. After the discussion of breeder reactor, we also discussed about the nuclear fusion, in which the combination of more than two nucleus having low binding energy per nucleon to form the larger nucleus having higher value of binding energy per nucleon with the liberation of large amount of energy. And this is quite different whenever compared with the nuclear fission, which is exactly opposite to the nuclear fission, because in the nuclear fission the breaking of the nucleus, heavier nucleus, take place with the liberation of energy, while in the nuclear fusion combination of nuclei take place to form the larger or the heavy nucleus with the liberation of energy. And that's why it is one of the important concept to discuss here. So dear friends, today in this part of this lecture we will discuss about the nuclear fusion, and at the same time we will discuss about some examples of the nuclear fusion. So here already we have gone through what is nuclear fusion. Nuclear fusion is simply whenever the two or more than two nuclei having low binding energy per nucleon combine to form the larger nucleus with higher value of binding energy per nucleon, and in this case a small amount of mass get converted into a very large amount of energy, and this process is called as the nuclear fusion. So it's very simple, that already we discussed in the previous way, and this is one of the example. This is one of the example in which here that indicates that indicates the combination of four number of hydrogen nucleus and gives the formation of helium nucleus with the liberation of positron and large amount of energy, 26.7 million electron volt. And for such nuclear fusion reaction a very high amount of temperature is required, and that's why these reactions are also called as the thermonuclear reaction. So dear friends, today in this part we will discuss some examples of this thermonuclear reaction, which are also called as the nuclear fusion reaction. So how this thermonuclear reaction take place and how these are observed here. Okay, so this is one of the example in which the nuclear fusion take place, and these are simply the stellar bodies. Among several fusion reactions occurring on the stars, and following are some important thermonuclear reactions, and out of this the first one is called as the carbon cycle, in which the carbon is the starting material for this reaction, nuclear fusion reaction, and at the end of reaction it will be again recovered. That's why it is called as the carbon cycle, and this is the main process of nuclear fusion in the stars with very high temperature or old stars, and this includes, these are the reaction. Here dear friends, you can see there are number of reaction in which in the first step carbon 12 nucleus combine with the hydrogen nucleus, and it gives the formation of nitrogen 13 with the liberation of Q1 amount of energy. In the next step, this nitrogen 13 which is formed here, again it will be converted to carbon 13 with the liberation of positron, and this carbon 13 which is formed here, it will again combine with the hydrogen nucleus to form the nitrogen 14 with the liberation of some amount of energy indicated by Q2, and this nitrogen 14 which is formed here, it will again combine with the nucleus of another hydrogen, and it gives the formation of oxygen 15 with the liberation of Q3 amount of energy. And this oxygen 15 which is formed here in the fourth step, it will be converted to nitrogen 415 with the liberation of positron. So these are the stepwise reactions of the carbon cycle, that how will in the next step in the last reaction of the carbon cycle, nitrogen 415 again combined with the hydrogen nucleus, it gives the formation of carbon 12. You see here in the earlier reaction you can observe this carbon 12 was starting material, and at the end of reaction it will be again recovered here. That's why these reactions are called as the carbon cycle, and with the liberation of helium nucleus. And that's why if you add all these reactions, then you will get the net cell reaction, and you will come to that here in the net cell reaction 4 number of hydrogen nucleus combine with one another at a very high temperature, and they will gives the form of helium nucleus with the liberation of positron and the liberation of 26.7 million electron volt amount of energy. So this is the simple reaction, but this simple reaction takes place in number of steps in which carbon 12 acts as the cycle. So that's why these reactions are called as carbon cycle. Another example is called as proton-proton cycle, and here it just like the carbon cycle. It takes place in young stars particularly. It is generally observed in case of young stars and low temperature, and it requires the temperature of 20 million degrees. And proton-proton cycle take place on the sun particular. So you can imagine how this is important, because we all are getting the large amount of energy then from the sun. So this is the tremendous amount of it is the source of tremendous amount of energy. So and this proton-proton cycle is responsible for the energy of sun. So you can imagine how this is important. So if you talk about the proton-proton cycle, then you will come this is also take place in number of steps. In the first step, two nucleus of the hydrogen get combined with one another and give the formation of deuterium with the liberation of positron and some amount of energy indicated by means of Q1. This deuterium, which is the isotope of hydrogen, again combined with hydrogen nucleus, and it gives the formation of helium with the liberation of Q2 amount of energy. And here in the third step, because already earlier two steps that we discussed here in the previous slide, and in the next slide, that is this helium nucleus, two number of helium nucleus get converted to helium 4 with the liberation of two number of hydrogen nucleus and with the liberation of some amount of energy indicated by Q3. That's why if you see the net cell reaction again you will get the same net cell reaction in which the 4 number of hydrogen nucleus will combine with one another to give the formation of helium nucleus with the liberation of positron and the 26.7 million electron volt amount of energy. So here it will be just similar, it will be just identical with the carbon cycle, though it is the simple reaction, but it takes place in number of steps in which one nucleus combined with another nucleus, and it gives the formation of an heavy nucleus with the liberation of some amount of energy. If we will discuss another example of this thermonuclear reaction, and these are called as the controlled thermonuclear reaction that takes place on the earth, and these reactions are possible with the heavier isotopes of hydrogen. Isotopes means the elements or the nuclei which are having the same atomic number but different mass number, and if the mass number is greater, then these are called as the heavier isotopes of hydrogen. And generally you know very well, or you should be aware, that two isotopes of hydrogen, one is the deuterium, another one is the tritium, and these are involved in this thermonuclear reaction. That's why these are called as the controlled thermonuclear reactions, and which are possible with the heavier isotopes of hydrogen. So dear friends, see here in the first step of this controlled thermonuclear reaction, in which the two hydrogen nucleus combine with another, it gives the one of the isotope of hydrogen called as deuterium with the liberation of positron and the 1.4 million electron volt amount of energy. Again, two isotopes, deuterium nucleus combine with one another, it gives the third isotope of hydrogen called as tritium with the liberation of another hydrogen nucleus with the 4 million electron volt amount of energy. In the third step, it is very important, dear friends, here the two different isotopes of hydrogen combine with one another, and it gives the formation of helium, and this helium is very important if you want to get the energy. And this helium with the liberation of neutron and the 17.6 million electron volt amount of energy. And here hydrogen nucleus combined with the one of its isotope deuterium, it gives the formation of helium-3 with the 5.5 million electron volt amount of energy. And in the third step, this hydrogen nucleus combined with its another isotope tritium to form the helium nucleus and the 19.8 million electron volt amount of energy. And in the last step here, you can see it just like this, two deuterium elements or the nuclei combine with one another, it gives the formation of helium nucleus and the 28 million electron volt amount of energy. So dear friends, if you will observe all the steps, then you will come to that this reaction number 3, it is the unique reaction, and it is the choice for controlled thermonuclear reaction, because in this case the two different heavier isotopes of hydrogen combine with one another, fused with one another to form the helium nucleus and neutron with the liberation of 17.6 million electron volt amount of energy. And that's why this reaction number 3 is the choice for controlled thermonuclear reaction. So dear friends, I think you got a clear idea about the thermonuclear reactions, particularly as these are the nuclear fusion reaction requires very high temperature. That's why these are called like the thermonuclear reaction. And in this part we also discussed about the various examples of these thermonuclear reactions or the nuclear fusion reaction, and which is one of the important type of the reaction whenever you want to get the energy, nuclear energy. So dear friends, in this way, today in this part we have completed the nuclear chemistry topic, which is one of the important topic given in the semester 5 syllabus of last year students of the graduation in science in chemistry. And in this way we have completed this topic. So dear friends, I don't think that you have any doubt, and in case any doubt, in case any problem, you can contact, you can ask. And at the same time, I request you all to solve some problems given in the text or in the reference based upon the same topic, nuclear chemistry. But still, again, in the next part of this lecture series, online lecture series, we will discuss about the review of nuclear chemistry, and at that time we will try to review all the topic that we covered till today in this online lecture series, and we will try to solve your difficulties also. So before that, if you have any doubt, any problem, you can ask, you can contact. So thank you, and we will resume again in the next part to review the nuclear chemistry, which is one of the which is one of the topic given in the last year for chemistry, physical chemistry. So thank you once again.